Hello dear learners, you're welcome to this tutorial. In this tutorial we are looking at areas of plane figures. So by the end of this tutorial, you will be able to understand concept of area. You'll be able to understand what plane figures are. You'll be able to determine the area of common plane figures. So this tutorial is powered by Hyota Virtual Learning, and I'm your math tutor, Ademola Folarin. So let's start learning. When you place an object on a surface, the total space occupied by such object on that surface is what we call the area of that object. Say for example, you place your book on your table. The total space occupied by your book on your table, it is the area of your book. And this we can say to plane figures, that area is the total space occupied by a plane figure. So what do we call plane figures? Plane figures are figures with two dimensions. We are familiar with them around us. Plane figures are figures with two dimensions. So example of them are what we have here, and we'll be looking at their area one by one. So this is a triangle. This is a triangle, three sides with the height in the middle. So area of triangle, the area of this figure triangle is equals to half base, which is where it's sitting on, multiplied by its height, half base times height. What if situation where the height is not known, however, a angle is given? Let's say angle of this place is given. Then if we say this place is angle B, this place is angle C, and this place is angle A. So if angle A is given, we can then say area of the triangle can be expressed as 1/2 the base, then this side C multiplied by the sine of A. Because from our trigonometric ratio, we have only substituted this height for C sine A. Remember, this is opposite and this is hypotenuse. So sine A will be opposite divided by hypotenuse, and that gives us the H. For a plane figure like square, the area of square is the length multiplied by the length, because a square is a plane figure in which all the four sides are equal. So the area is L squared. It's a quadrilateral similar to rectangle. So we measure them the same way. Area of rectangle is the length of this side multiplied by the length of this side, which is length times the width or the breadth, as the case may be. Another interesting plane figure is this figure. We call that trapezium. A trapezium. The two sides facing each other here, they are parallel to each other, and we have the perpendicular height. So the area of trapezium is equals to the half of sum of these two sides, that is side A plus side B, multiplied by the height. That's the area of trapezium. I know you're familiar with circle, a round plane figure. So the area of circle is gotten by understanding that from the center of circle to any point on the circumference is called radius. Is radius. So if this radius extends to the other side, it completes just like a straight line this way, is called diameter. So area of circle can be expressed as pi r squared. Remember, The pi is as a result of it being a round figure that cycles 360 degrees. So area of circle is pi r squared. We even have a song for it. To pi r circumference of circle, pi r squared is the area. So area of circle is pi r squared. And when some part of circle is cut out, it gives us a sector, just as what we have here, sector. Let's say this, consider this circle. If we cut this and we cut this place out, we have a sector. A sector is bounded by arc, that is, arc is just a portion of circumference. When you have a portion of circumference bounded by two radii, we have a sector. So area of sector is equals to, because sector is just a portion of a circle that spans a particular angle. So that span of angle will be ratio to 360, that is theta over 360. So since area of this is just a portion of circle, multiplied by the area of circle, by r squared. So the area of sector is theta over 360 by r squared. And it can as well be expressed as 1 over 2 multiplied by square of the radius multiplied by the theta. But at this point, the theta must be expressed in radian and not degree. That's interesting. Okay, we've been able to revise areas of these plane figures. Let's try to solve problems involving them. We take a look at this problem. We are to calculate the area of this figure. The very first figure bounded by side QR, RS, SP, and PQ is what we call trapezium. And remember, for this being a trapezium, we recall that the formula for area of trapezium is half of the sum of the upper and the lower side, that is A plus B, multiplied by the height. Here we can say let the height take this point. This is our height. However, the height is not given. The height h is not known, but this angle is given. So if we cut out this portion, let's say we are now have M here, this point as point M. So we have a right angle with one of the angles known and the opposite side of it is needed. With what we have here now, using our trig ratio, we have opposite and hypotenuse. So that is sine. We can then say sine 42 degrees equals opposite, which is height, divided by the hypotenuse, which is 5. So we can say 5 sine 42 is equals to the height, right? Then we can bring that into this. We substitute that into this by saying the area becomes 1 over 2, open bracket, the sum of 6 plus 10 multiplied by the height, which is 5 sine 42. So going further, that becomes 1 over 2 multiplied by 16 multiplied by, here you can try this with your calculator. You do 5 multiplied by your sine 42. Sine 42 can be gotten from our calculator. We can do that. Sine 42 is 0.6691. So if we do this, this will give us 8 multiplied by 5 multiplied by 0.6691. And if we multiply these together, that's 8 multiplied by 5, that's 40. Multiplied by this value, we have 26.76. So we can say the area of this figure is 26.76 square units, that is centimeter square. Remember, area is always in square units. So we've been able to successfully answer that. Let's look at the second part. At this second part, this is a triangle. Remember, the formula for triangle is the area of triangle is half base times height, or another part we can say half the side of base. Okay, let's consider this. If we call this one A, we call this B, we call this C. So here we are given angle C. We have side A and side B. That will be AB sine C, yes. So we can use this to say 1 over 2. The A, that's the side that faces angle A, that's 5. The base is 13, and sine of 51. If we try out this first, that is, we multiply the 5 by 13, that gives us a very interesting value, that's 65. So we have 1 over 2 multiplied by 65 multiplied by sine of 51. So sine of 51 using our 4-figure table will give us 0.77. Then we can multiply this all through by saying 0.77 multiplied by 65. That gives us 50.05 divided by 2. You divide your answer by 2, that gives you 25.02 centimeter squared. That's area of this triangle. Isn't that interesting? Okay, so let's take another example. We have another example here that says the angle of a sector of a circle of diameter 8. So if we try to bring out a circle, let's try to sketch a circle. Okay, let me sketch a bigger one. Yes. If this is the diameter now, let's run the diameter. The diameter is a line that divides a circle into 2 equal parts. If that means it must run through the center. So we have the diameter here. What is then asked? The diameter is 8 centimeter. That is, from here to here is 8 centimeter. It forms a sector. That means if it's forming a sector, we need another part to make it a sector at a particular angle 135. Maybe a sector at angle 135. This now has become a sector, right? That's what we need. So not to confuse ourselves, let's try to look at this as our concern. Yes, this is the sector of concern, where we can, for easy understanding of it, let's call this place angle, the part A, the part B, and this sector span angle 135 degrees. So we are then asked to find the area of this sector. Interestingly, we've discussed something of this. Here we have the diameter to be 8 centimeter. So we have to first determine our radius. Radius is half of diameter, which is 8 divided by 2, which is 4. Our radius is 4 centimeter. That's known. So we must understand that before moving on. Now we can move on to consider the area of this sector. Recall the formula says the area of sector equals theta divided by 360 multiplied by area of circle, which is pi r squared. So we already know our theta to be 135. That gives us 135 degree divided by 360 degrees multiplied by pi, which is given to us here 22/7 multiplied by the square of radius. So if we do this, it is very easy for us to just say we multiply this 135 by 22. That gives us 2970. Then we multiply by the square of 4, which is 16, all divided by, when we multiply 360 by 7, that's 2520. So from here, we can, with the help of our calculator, work things out by saying the numerator, which is 2970, is multiplied by 16. Then we can divide whatever it gives us by 2520, which is the denominator, and we are left with 18.857. You can confirm that with your calculator. That's the area of sector. And here we can approximate this to a whole number. Sometimes question may ask us to do that. So to 19 centimeters squared. Remember, area is always in square units. So if we understand this, it's a very good thing for us. We can quickly flash back to where it all started, where we have discussed the concept of area. So I want to believe now you can remember all this. Remember that area is the total surface occupied by an object. That is the area of an object. So, and that brings us to the end of the class. I want to believe that by practicing more, you get more understanding of the concept discussed. Thank you.